Hello everyone, welcome to the Somnia Developer Education Series, or Somnia 101. In this session, we are going to learn how to read and write from a smart contract. This is part 1 of the series, and we are going to focus on carrying out read operations for a smart contract. Let's get started. A read operation is when we query a smart contract without changing any states on the blockchain. You can think of it like asking a question and you get data back without modifying anything. Read operations are free. They don't require gas because they don't trigger a blockchain transaction. Examples include checking a user's balance by simply calling it balance, or fetching a DAO proposal, or reading a public variable like a contract owner that has been declared in a smart contract. So these functions are usually marked as view or pure in Solidity. A write operation is when you send a transaction that changes the state of the blockchain. This could be minting a token, updating a mapping, transferring funds, or voting in a DAO. Write operations cause gas because they require the network to process and validate the change. These are usually functions that don't have view or pure modifiers. When you perform a write operation, your wallet will prompt you to sign and confirm the transaction. We begin by creating a directory for our project called Somnia Read Write. So in this directory, we are going to first start by initializing a Hardhat project and select the TypeScript with Vim. So select all the options to initialize the project, and now that we have our project initialized, we import it into a code editor. We replace the default code with a greater Solidity contract that takes in just two functions, the greet and the change name. And then we name this greeter.so. So for our ignition modules, which we'll use for deployment, we'll change it and then pass in the argument to deploy the project. Compile the Hardhat project, and after it has successfully compiled, we want to set up the network information where we'll deploy the smart contract. So we are deploying to Somnia and we'll pass in the RPC URL and also the private key to a wallet address where we have STT tokens that would use to deploy this smart contract. And we rename the file to greater.typescript, and we run the command ignition deploy to deploy to the Somnia network. Once this is deployed, we have our smart contract there that we are going to be performing read operations on. Next step is to create the app UI where we are going to have our project. It's a Next.js project, and would begin by looking at the index file and replacing all the default context with a simple hello world message. Can go ahead to create new pages where we would have our wallet interaction. You'll find the example code in the link placed in the comments of this video. Copy and paste the code. We have a couple of states where we would register address and a function to connect to MetaMask and also disconnect the wallet. This would use in part 2 of this series. Wallet provider is made available in the wallet's context and passed on to the use wallet. Here would have all the methods for the app states. So we also have a navbar that you can also copy from the documentation. It's linked in this video, and all you just have to do is have a use wallet state where we want to pass the global state from the app. So going back to the app itself, we want to import wallet provider who imported from the wallet itself would have the access to all the methods in the wallet provider. And also for aesthetics, we are importing the navbar as well. The return statements would be able to update that and return the wallet provider and the navbar. So this is what our app looks like when we run it. So you can see how beautiful that looks. To continue with our application, we would need to be able to read the ABI. So we create an ABI.json file and go inside the artifacts contracts directory and copy the entire ABI JSON code. So it's JSON formatted. We'll copy in between the array all of the content. This will enable us to read and write to the smart contract. You can think of this as an API for traditional Web2 developers. So we declare an ABI.js file, passing the ABI JSON file in there. Go back into our wallet provider inside the wallet.js file. Import the Somnia network from VM and also import two methods from VM. That is the create public client and the create wallet client. We'll use create wallet clients in the next part in the series, but we declare a public client variable where we call the create public client and pass in two arguments. So the two arguments are the chain, which is Somnia Testnet that is available from the VM chains, and then a transport protocol, which is going to be HTTP. These public clients will enable us to carry out read operations on our smart contract. And for the particular smart contract function that we want to call, want to be able to just perform a read operation on, it is the name function. We just want the name that was set in the greeter contract. So you can see all of the other functions in there. So we'll declare a function to read the name back in our wallet.js file, and then it takes no argument basically. So it's a promise, an asynchronous function. So using a try catch block, we are going to call the public client, which reads from the create public client, and passing the method read contract, where we pass in the contract address of the deployed contract. We are going to import the ABI file so that we'll be able to read that particular function from the ABI. Then passing the ABI as an argument as well to the public client, the read contract, and typing the function name. The function name here is actually name. So with this, we'll be able to call name in our application and it will simply return the results of the name. It's a try catch block, passing an error component in case it throws an error. It simply logs it to the console with an error message. So with this, we are ready to pass in the name method to our wallet context, and this is available via use wallet to the rest of the application. Next, we update our index.txs file. We import the use wallet hook from the wallet file, and we want to be able to update the state of the name. We'll first of all call name from use wallet, so it's now available in the application, and then we declare a state where we want to set the name when we load it from calling the name function, which is available to us in the via use wallet in the wallet file. So we update the user fed hook by having the function call the name function and set it to a user variable where we call the set name state and set the user in the set name. So it's a try catch block. You can also log an error to the console if there are any errors. So with this, we are ready to load this information in the UI of this application. All we are just passing is the name, and then with the use effect hook, once the name is received, the app stops loading. So we can update the UI and pass the new name state using a ternary operation to check if it has loaded. Then it should pass the name in a simple paragraph, and if it is not yet loaded, it should show the state as loading. Save the file and run the commands to run the code by running npm run dev. So we can go into our UI to view this. So once the UI loads, you would see that the state is set to loading, and then it loads the name, which is Emmanuel. Thank you. And with that, we have come to the end of today's session. Thank you for watching to the end of this video. Kindly leave your questions, comments, and feedback. You can also ask your questions on Discord in the dev channel. I'm always available to answer. Please like the video and subscribe to the channel. See you in the next one.